Okay, here is a video on how we're going to evaluate logs. And this first part is no calculator. So the first part just says to write as an exponential function and then evaluate. And if you remember, if we would read this out loud, this is log base 7 of x equals 2. So to rewrite it, the 7 becomes the base, and then these two switch sides. So we get 2 to the x. And now that we've rewritten it, we can easily solve this because we know 7 squared is 49. On the next one, if we do the same thing, this would be 5 to the third power equals x. So 125 equals x. Done. Okay, number 3 is the same as number 2, so we're not going to redo it. Let's look at number 4. This would be 25 to the 1/2 power equals x. Well, anything to the 1/2 is the square root, and the square root of 25 is just 5. On the next one, I have 8 to the 1/3 power equals x. So that is the cube root of 8, which is 2. Over here, this would be 121 to the 1/2 power, which is the square root of 121, which equals 11. We're looking 11. Okay, number 7, same idea. This would be 6 to the -2 equals x. Well, anything to the negative power, to make it positive, we write 1 over. And so that's going to give us 1 over 36 as our final answer. Over here, we'd have 3 to the -3 equals x. So to make it positive, it'd be 1 over 3 to the 3rd. So we just get 1 over 27. On the last one, this would be 2 to the -4 equals x. That's 1 over 2 to the 4th. So we get 1 over 16. Okay, so on these next ones, if you have your notes that we did on solving with the same base, at the top we have a chart, and it's going to be really helpful if we use that chart to be able to evaluate some of these logs. So let's take a look at this. So on number 10, there's no x, and right now we don't instinctually know what log base 3 of 81 is. Hopefully, after we start to do a lot of these, then you can see what the answer is without having to rewrite it. But one way to approach it is to rewrite it. So I'm going to set it equal to x. So I'm going to say 3 to the x equals 81. So 3 raised to what power equals 81? Well, if I look at my chart, I see an 81 over here, but that's 9 squared, and I need a 3, so that's not going to work. I see it again over here, and 3 to the 4th is 81. So I know on this that 3 to the 4th power would equal 81. So x has got to equal 4. So this problem, we just say it equals 4, because technically we added that x in there. So it just equals 4. So 4 would make that statement true. So if we rewrite the next one, 4 to the x equals 64, because remember we tagged that on to the end. We got to figure out what number would make that true. So if we're looking at this, we got 64 here with an 8. That doesn't work, but we got 64 here with a 4. 4 to the 3rd is 64. That's what we're looking for. So to make this true, it would have to be to the 3rd power. Okay, so on this one, if we were evaluating this one, that's easy. That's 7 to the x equals 49. Most of us already know that. That would just be 2. Over here, if we rewrite this one, that would be 2 to the x equals 32. Well, what is that number? Well, 2 to the 5th power equals 32. So log base 2 of 32 must just equal 5. Okay, over here, we got to add the numbers, but we got to figure out what they are first. So to help us figure out what they are, we can say 5 to the x equals 25. Well, that's got to be 2. This one we can think of 3 to the x equals 27. Well, that's got to be 3. So when I add 2 plus 3, I just get 5. Here, this is going to be 3 times whatever makes this true. And what makes that true, 2 to what power is 8 is a 3rd. So this is 3 times 3, which is 9. Okay. If we go to the next part of our notes, we got to remember what E is. And remember, E is not a variable. E is a number, and it's about 2.718. Okay. So if I had this and we were rewriting as a log, it would be log base E of 70 equals X. But from now on, we're not going to write log base E. Instead of writing log base E, we're going to replace it with ln of 70 equals X. And ln stands for the natural log. Okay. So this last part is getting you ready for the solving. We need to know how to put this into our calculators. So that's what we're going to practice. So if you want to get your calculators out, then we are going to look at these. So the first one, oh, but first I should mention over here on 1 and 2, they don't have a base just like we had on 4 and 3. And the deal is when it doesn't have a base, just like the square root has an invisible 2, this is an invisible 10. So when we don't write the base, it's an invisible 10, which we're not going to need to punch into our calculator, but we're going to need that for something else. So I just want to point that out. Okay, so in our calculator, if we wanted to do log of 78.5, I'm just going to show you one of each type and then you can try it on your own. The log button is over here on the left, so you're going to hit log and then 78.5. For these, you don't need to, if you're just getting a value, you don't need to type in the parentheses and then hit enter. And we get this. So to we want thousandths. So to 3 decimal places, we get 1.895. Okay, but what if it has a base like number 3? Well, the way we do that is we go to the math menu. And in the math menu, we need to go up to option A. And then we're going to do log base 4 of 80. And now we've got it in there and we can just hit enter. And now we've got our answer. So we get 3.161 if we're rounding to the nearest thousandths, because that's 3 decimal places. The last thing was the natural log of 50. And remember, natural log is the same as log base E. We're not going to type it in as log base E. We're going to type it in as the natural log. And the way we do that on our calculator is right below the log button is a natural log button. So if we do natural log of 50, and again, if it's just evaluating them, you don't need to enter the parentheses. And we get 3.912 if we round to the nearest thousandth, because thousandths is 3 decimal places. Okay, that is the lesson.